Hello students. In the previous episode, we discussed about drift velocity and relaxation time. Today in this episode, we are going to find an expression for drift velocity in terms of relaxation time. Consider a conductor having length L across which a PD of V volt is applied. We are considering a conductor of length L across which a PD of V volt is applied. Suppose that a current of I ampere flows for a time of t seconds. Suppose that a current of I ampere flows for a time of t seconds. Here, the electrons will move towards the positive terminal of the cell. Here, the electrons will move towards the positive terminal of the cell. So here we know that before applying a PD across the conductor, the initial velocity of the electron is 0. And we know that the final velocity is the drift velocity of the electron. So we can write the final velocity is equal to Vd. And we know that relaxation time is equal to tau. So from these equations, from these details, we can find the force act on each electron. So therefore, force act on each electron F is equal to QE. That is, we know that intensity of electric field is equal to F by Q. From this equation, we can find out equation for force F is equal to Q into E. And here we know that the charge is negative charge, or here the charge is provided by electron. So this charge can be replaced by the charge of electron, that is minus E. So the equation for force is F is equal to minus E. We know the basic equation for finding force, that is F is equal to ma. We know that the basic equation for finding force is F is equal to ma. So here we got two equations for force, because the left hand side of first and second equation was equal, so we can equate the right hand side of the equation, that is ma is equal to E. From this equation we can find out an equation for acceleration. Acceleration A is equal to minus E by m. So we got an equation for finding the acceleration of the electron. Now we know the first equation of motion. What is the first equation of motion? First equation of motion, that is V is equal to U plus AT. V is equal to U plus AT, where V is the final velocity and U is the initial velocity, A is the acceleration and T is the time. So we are going to substitute the values of V, U, A and T in this equation. So we get Vd, the final velocity is drift velocity. So Vd is equal to, we know that initial velocity is taken as 0. So for U, we have the value 0 here, plus we already find an equation for acceleration of the electron, so we can substitute the value of acceleration here, that is minus E by m. And for time we have relaxation time tau. So the equation for drift velocity Vd is equal to minus E tau by m. So we got the relation between drift velocity and relaxation time, that is Vd is equal to minus E tau by m. So in this equation there is a negative sign, right? So here this negative sign shows that electrons drift in a direction opposite to the direction of electric field. That is, here the negative sign shows that electrons drift in a direction opposite to that of direction of E. Now we are going to discuss the relationship between drift velocity and electric current. Now we are going to discuss the relationship between drift velocity and electric current. So for that we are considering a metallic conductor of length L as shown in the figure. We are considering a metallic conductor of length L and area of cross section capital A. Here let n be the number of free electrons per unit volume. Let n be the number of free electrons per unit volume. So it is easy to find the volume of the conductor. Here the volume of the conductor, is equal to A into L. That means area of cross section into length. That is the method to find the volume of a cylindrical conductor. So the next step, total number of free electrons. Here total number of free electrons, we have to find the total number of free electrons. We know that n is the number of free electrons per unit volume, and we already know the total volume of the conductor also. So to find the total number of free electrons, we have to multiply number of free electrons per unit volume into the total volume of the conductor. So here total number of free electrons we get NaL. Now we have to find out the total charge. Total charge of these electrons. We got the total number of electrons here, and we know that charge of one electron is E. So we have to multiply charge of one electron with the total number of electrons. So here the total charge of electrons we get ENAL. Then what is the equation for finding current? We know that current I is equal to Q by T, that is charge by time. We already got the total charge in the conductor. We can substitute the value of charge in this equation. So we get I is equal to ENAL by T. So the value of current we got it, I is equal to ENAL by T. And here we know that L by T is equal to Vd. That means here we take L as the distance because in this conductor the electron can travel maximum L distance. So it turns as the displacement divided by time, and displacement divided by time is the velocity. Here the velocity is drift velocity, so L by T is equal to Vd. So we can rewrite the equation for finding I is equal to N A V D E. For L by T we substitute Vd. So we get N A V D E. So we got the relationship between drift velocity and current, that is I is equal to N A V D E. So today we deal with two topics. First one was the relationship between drift velocity and relaxation time. So we got Vd is equal to minus E tau by m. So here we say that the negative sign shows that the electrons drift in a direction opposite to the direction of intensity of electric field. Okay, the next topic was relationship between drift velocity and electric current. So we find the relationship between drift velocity and current as I is equal to N A V D E.